Hi everyone, we are going to be taking the 3.7 notes today, okay? And on the first sheet there are some really important facts. I decided to have them typed out for you instead of having you write them down. It's kind of a lot. And then we're going to do 3 examples together. So a few things, let's go down the list. Using S of t or x of t is talking about the position or like the height of an object. V is used for velocity and A is used for acceleration. And so this is like the first function. Velocity is the derivative of the first function and acceleration is the derivative of the second function. So original, first derivative, second derivative, and it goes in that order. All right. The word initially has a definition. It literally means when time equals 0. So you're going to see that in word problems and you need to know what to do with that word. Initially means time equals 0. Instantaneous velocity, we're going to kind of drop the instantaneous. We're just going to say velocity, but it means instantaneous. So it is a derivative. It is the first derivative, okay? The derivative of the position function. Speed is the same as velocity, except velocity is the one that has a direction. So I could say 25 miles per hour. That's my speed. And then I can say negative 25 miles per hour. They have the same speed. It's just that this one is going to the right and this one's going to the left. So 25 miles per hour is the speed for both of these numbers. Speed can never be negative, okay? So speed is never negative because it does not take into account direction. But if I say, what's the velocity? You can totally say, oh, the velocity was negative 25 miles per hour, meaning it was 25 miles per hour going to the left or going south, whatever that, the problem is about. Displacement, it's where you end up minus where you begin. It's the difference of two locations. It's a distance, okay? But it's not total distance traveled. And I'm going to do an example of that. So it's going to be S of the time at the end minus S of the time at the beginning. So S of T of 0 means the beginning time. I'm going to write T sub E as T ending, time ending, and time beginning. Total distance traveled, we're going to do an example of this too, is all the distances traveled together, okay? Like if I have a particle, it goes 2 feet to the right, then it goes 7 feet to the left. So it went 2 feet to the right and then it went 7 feet to the left. Let's say it's an ant, whatever. So the total distance the ant traveled was 2 plus 7, 9 feet. But the displacement of that ant, okay, is 7 minus 2, 5. All right. End minus beginning. And it'll probably be, I'll give you, you'll know which one's the end, which one's the beginning. And in this picture, it's not very clear, but we're going to do examples about that. All right, so super duper important. This is, I can't even stress how important this is. So I'm going to ask you, over what time interval is the particle moving to the left? You're going to look for when velocity is negative. I'm going to say, when is the particle moving to the right? You're going to say, whenever velocity is positive. And when is the particle stopping? When is it at rest? It's not moving at all. It's when velocity equals 0, because that would be speed with direction. So when the speed or the velocity is 0, nothing's moving. All right. And then for this one, it says when the particle is farthest to the right, you have to look for when velocity changes from positive to negative. And then look at this statement. We're going to use a number line. I'm going to, again, these are just things to know, and then I'm going to do examples. This one, it says when velocity is increasing, acceleration is positive. When velocity is decreasing, acceleration is negative. We're going to do a number line also, but it's going to be a different number line, okay? This is going to be the velocity number line. This is going to be the acceleration number line. All right. And then there's going to be questions that say, okay, so over what time interval is the particle slowing down? So you have to compare velocity and acceleration and see where they have opposite signs. So what you're going to do is you're going to put two number lines underneath each other, the velocity and the acceleration. Literally, you're going to line them up, and you're going to see where, so compare two number lines. You're going to see where velocity and acceleration have opposite signs, like positive, negative, or negative, positive. And then I'm going to ask you, when is the particle speeding up? You're going to look at the same two number lines, velocity and acceleration, and see where they have the same sign. So positive, positive, or negative, negative. All right, let's do some examples so that all comes together. Example 1. So the position of a particle moving along the x-axis, so it's like going back and forth. Imagine this is the x-axis, it's traveling that way, traveling that way, traveling that way, back and forth, is given by the function s, which is position, t cubed minus 6t squared plus 9t, where s is in feet, time is in seconds. All right, so let's find the velocity at time t, which means find the derivative. So velocity is the derivative of position. So what's the derivative of this polynomial? It is 3t squared minus 12t plus 9. There it is. It says, what's the velocity after 3 seconds? So now we want v of 3. That means we're plugging in a 3 into velocity. 3 times 3 squared minus 12 times 3 plus 9. Let's see, what is that? That is 27 minus 36. Negative 9%. Oh, that's 0. And you need units because it is a rate. Okay? When is the particle at rest? Remember, on the notes, when is the particle at rest? It is at rest when velocity equals 0. That means it doesn't have a speed. So you set velocity equal to 0. You set this function, 3t squared minus 12t plus 9, you set it equal to 0, and you solve it. You have to factor. So I'm going to go ahead and factor out a 3 because it's factorable. And then I'm going to notice that that is further factorable. So t minus 1, t minus 3. And I'm going to see that at t equals 1 and t equals 3 seconds, we need units, the particle is resting. All right. When is the particle moving the negative direction? And in E, when is the particle moving in the positive direction and the negative direction? Positive means to the right. Negative means to the left. We need a number line for both of these questions. So I'm going to start with time equals 0, and then time equals, there's no end. This is going to be the velocity number line because direction, the word direction, deals with velocity. It's not position, it's not acceleration. So if you see direction, you're dealing with velocity. And on this number line, you want to plot the resting points. So 1 and 3. These are the resting points, resting times, okay? Then you're going to pick values in between these intervals that you like. For example, between 0 and 1, I'm just going to randomly pick a half. And I'm going to plug in that 1/2 into the velocity function. So where's my velocity function? Here's velocity. I think I'm going to use the factored form of velocity. Velocity is right here, okay? And if I plug in 1/2, let's see what happens. 1/2 minus 1, that's negative. 1/2 minus 3, that's also negative. So negative times negative is positive. What about a 2? Between 1 and 3 is a 2. 2 minus 1 is positive. 2 minus 3 is negative. Positive times negative is negative. And if you test that region, it's going to look like that. This number line is going to help us answer both questions. It says, when is the particle moving in the positive direction? It looks like it's moving in the positive direction between time 0 and 1, union, time 3 to infinity. When is the particle moving in the negative direction? It looks like between time 1 and 3, in the interval 1 and 3. So when you get to this often people struggle with question F. What is the total distance traveled during the first 8 seconds? For total distance traveled, you need a time and position chart. On this chart, you're going to plot the beginning of the time interval, which is 0, it always starts at 0, to whatever they say in the problem, so 8. And in between those, you have to plug in all the resting times, which were 1 and 3. Okay. And in using these 4 values, so initial time, ending time, okay? And in between those, all the resting times that we got when we factored velocity. Then you plug into the position function, which is the original one way at the top. And I did this before class for you. So when you plug in 0 into position, it's 0. When you plug in 1 into position, you get 4. When you plug in 3 into position, you actually get 0 again. And then when you plug in 8 into position, you get 200. Now, total distance traveled is going to be all the distances traveled added together. There's going to be no distance, there's going to be no negative distance. So the distance between 0 and 4 is 4. The distance between 4 and 0 is also positive 4. So you go 0 to 4 is positive 4. Then you backtrack. Yeah, you go to the left, but you are still going a distance of 4. Distance is positive. And then you go to 200. So the distance between 0 and 200 is 200. Add up those 3 numbers, 4 plus 4 plus 200. The distance total distance traveled is 208 feet. And then we have to draw a diagram to illustrate. So here we've got the x-axis. Okay, let's say this is 0 on the x-axis. So at time 0, and the x-axis is really s of t. It's just position. So at time 0, we're going to start. So above the position of 0, I'm going to put a dot. The numbers on this line represent position, okay? And I'm going to put a little t equals 0 by that dot. It looks like over the next 1 second, I'm looking at this chart and I'm representing it in a picture. Over the next 1 second, I'm going to travel all the way to position positive 4. So I'll put position positive 4 here, and I'm going to show a line with arrows moving to the right. Why moving to the right? How do I know that? Well, look at this number line over here. This tells me direction. Over the first second from 0 to 1, the particle was traveling to the right. So I'm going to put a dot here, right here. Okay, and I'm going to write t equals 1 next to that dot, because I also know that 1, where was it? That 1 was one of my resting times. A resting point is when the particle stops, doesn't move, and does a U-turn. It changes directions, because the next interval of time from 1 second to 3 seconds, I have to be traveling to the left. So now I literally show in my picture traveling to the left. But it looks like how much to the left do I go? It says that at the 3 second mark, my position s of t lands at 0. So right here again. And then I'm going to put a little time equals 3 here, right next to this dot. And then after time equals 3, if you look at the direction number line, I make another U-turn and I go to the right. So I'm making a U-turn. And my number line here shows me that I'm going to be traveling in the positive direction forever after this. So I don't need to stop. But I do want to show that at time equals 8, I'm at a position of 200. So 200 on this number line. Okay, this is obviously not to scale, but I'll put 200 over here on this number line, and I'll put a dot here that says time equals 8. So this is how my particle has traveled. So this was a distance of 4, this was a distance of 4, and this was a distance of 200, meaning a total distance of 208. All right. Let's go do another one. So problem 2. It says the position of a particle is given by the function, here it is. This is position. So this is F, like the original. Feet and seconds. Find the velocity at time t. All right, so velocity is going to be the derivative of s. And so I'll have 2t minus 8. That is the derivative. It says, what is the velocity at 4 seconds? So v of 4. That means plug in a 4 into this function. 2 times 4 minus 8 gives me 0, and it's feet per second. Okay? When is the particle at rest? Means set velocity equal to 0. Oh, I'm going to add a y, okay, to this problem. So I want us to justify. So that means set, when you see that question, you have to set velocity, which is 2t minus 8, equal to 0, and you have to solve it. So when you do, you get 4. So my answer is t equals 4 seconds. What is the y? What is the justification? Because velocity equals 0. That's the justification. When is the particle moving in the positive direction? When is the particle moving in the negative direction? You know that you have to do a velocity number line. So, number line. Time is 0. Time goes on. We don't have negative time. Remember, on this number line, you plot what? You have to plot resting times. That's when velocity is equal to 0. See? Particle is at rest. So you put a 4, and then that's the only one you have. And then you test these intervals. So you pick your favorite number between 0 and 4. Mine is going to be a 1. And I plug it into velocity. So here's velocity. Where's velocity? This is velocity. And I plug in, let's say, whatever your choice is between 0 and 4. I'm choosing a 1. 2 times 1 minus 8. That's negative 6. I don't care about the 6. I care that it's negative. Pick a number between 4 and infinity. I'm going to choose a 5. Plug it into velocity. 2 times 5 minus 8, that's positive. So, when is the particle moving in the positive direction? Here. From 4 to infinity. Why? Let's add that to the question. Because your justification to why the particle is moving to the right or the left in the positive or negative direction is velocity is greater than 0. Velocity is positive. When is the particle moving in the negative direction and why? Looks like it's from 0 to 4 because that deals with velocity. Velocity is negative. Find the total distance traveled during the first 10 seconds. That means I need a number line. Not a number line. A t-chart. First 10 seconds, remember I told you initial time, ending time, and in the middle any resting times, which we found was just 4. Plug these 3 values into S right here. Okay, let me look at my work here. And when you plug in a 0 into S, you get 12. When you plug in a 4 into S, S of 4, you get negative 4. And when you plug in a 10, you get positive 32. All right, what's the distance, physical space, between positive 12 and negative 4? 12 minus negative 4 is 16. What is the physical space, the number of units between negative 4 and positive 32? It's positive 36. So like 32 minus negative 4. Add these two together. The sum is going to equal 52 feet, total distance traveled. You know what I didn't ask? I didn't ask for displacement. So I'm going to add a question over here. What is the particle's displacement over the first 10 seconds? Okay, displacement, literally, the definition of displacement is end position, so position at 10 minus beginning position, position at 0. End, the position at the end time minus the position at the initial time. So you do 32 minus 12, and the answer would be 20 feet. All right, draw a diagram. Okay, so we have our x-axis. Here is position 0. Okay, so position 0, let's say. And where are we? At time 0, we're at position 12. So my dot is not going to be above 0 because this would be a position of 0. So let's say this is 12. My first dot, and it's going to say t equals 0 next to the dot. This is where I begin. I'm starting on the x-axis on positive 12. I'm not starting at the origin. So over the first 4 seconds, which way do I travel? It looks like I travel to the left. So I start going to the left for 4 seconds. What position do I end up over those 4 seconds? So I travel 4 seconds. Look, time equals 0 to time equals 4. I have to end up at position -4. This is position 0. So let's say -4 is here. So I have to go all the way to -4 and put a dot. And next to that dot, right, time equals what? 4. Remember that 4 was a resting time. Remember? Look, resting time. Time equals 4, resting time. That means it pauses, it stops moving, and it does a U-turn. It does a U-turn at 4 because it changes direction, right? Look, changes direction at 4. And forever goes to the right after this, forever. Like so. But right where I see a position of 32, so if this is 12, 32 is like way out here. I'm going to put a dot, even though it's not changing directions, and I'm going to write time equals 10, because that's what the time is. All right, one more. So, and I'm not going to do G, and I'm not going to do H because it's just, we did 2 already like that. And I'm actually not going to do E or F. So traveling up and down would be basically a velocity. Traveling up means going to the right or in the positive direction, right? Positive direction. So that you would look at your number line and you'd see where velocity is 0. Traveling down is code for negative direction, like we did in those other 2 problems. And you would look at your number line and see where velocity is negative, right? Use velocity number line. Okay, so I won't do those, but I do want to do the first 4. All right, so there's a ball, it's thrown, blah, blah, blah. Here's its position. Okay, and if you notice, just for a second, 96t minus 16t squared, that is actually an upside down parabola. All right, so it says where this is t and this is s of t. All right, what is the maximum height reached by the ball? You guys, if you just take a moment and factor the position function, you can take out negative 16, leaving you with t squared plus 6. That's how it factors. Sorry, I didn't mean to scratch that. I didn't want to factor out a 16. I want to factor out a 16t. If I factor out a negative, so this is s, negative 16t, that'll leave me with t minus 6, which means the position function has a 0 at 0 and a 0 at positive 6. Look. And it's an upside down parabola, which should make sense because when you throw a ball, it looks like that anyway. So this is times 0. Apparently 6 seconds later, it's going to hit the ground, is what we know so far. Upside down parabola. It says, what's the maximum height reached by the ball? So maximum height is here. And you can guess that it's 3, but I don't want us to be guessing. I want us to use calculus. Maximum height reached by the ball is here. That's where we have a horizontal tangent. So when you see the word maximum height, what you should be thinking is horizontal tangent. And when do you get a horizontal tangent? When the first derivative equals 0. When velocity equals 0, you guys, which is the derivative of position. All right, so what is velocity? Let's get the derivative of 96t minus 16t squared. The derivative of 96t is 96. The derivative of negative 16t squared is 32t. You set that equal to 0 because that's how you do a horizontal tangent. And it turns out that sure enough, time equals 3 when you factor, okay? You will see that time equals 3. And that's how you do it with calculus. You are not to say, oh, I think the middle of 0 and 6 is 3, so it's got to be, you know, in the middle of 0 and 6. You're going to do the derivative equals 0 for this. All right, that's the answer to the problem. Next, when does the ball strike the ground? I mean, look. So you throw it here. It goes up, 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 down, 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 boom, hits the ground. So basically, when does the ball strike the ground? When the height, aka s of t, equals 0. So you are setting s of t equals 0, which we did right here. Our s of t, which we factored into negative 16t, t minus 6, you set it equal to 0, and the two time values are t equals 0 and t equals 6. But you have to kind of know how to answer the question because it says, when does it strike the ground? At t equals 0 is where it actually takes off from the ground, so you don't want to include that in your answer. You want to say at time equals 6. What's the because? Because s of t equals 0, because the height is 0. Striking the ground means the height of the ball is 0 above the ground. What is the velocity of the ball when it is 80 feet above the ground on its way up? Okay, now hold it. Here it is on its way up. Here it is on its way down. So when it's 80 feet above the ground, this phrase, when 80 feet above the ground, that deals with position. So this is a two-part problem. We have to set our position function equal to 80, and we have to solve it. But it's not going to be over because it's not going to answer the question. So when we set our position function equal to 80, let's put everything on one side, moving everything to the right side here. Okay, it's factorable by a 16. And then this is also factorable into t minus 5, t minus 1. It looks like at t equals positive 5 and positive 1, look, t equals 1 and 5, we will be at a height of 80 on the y-axis, here and here. Okay, I want to know the velocity. Which one of those times is the one on its way up? So look, up, 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 down, down, down. Clearly, the one where it says t equals 1 is on its way up. So it says, what's the velocity at that time? So to end the problem, we want to plug in 1 into velocity. This is going to be our answer. And when we plug in 1 into velocity, where's my work? I don't want to do my work all over again. Well, it's okay. What do we get when we plug into... Sorry, I gotta find my work here so I don't repeat everything I've done. Okay, I can't find it, it's okay. So when you plug in 1 into velocity, where's velocity? We found velocity, it's right here. This is velocity. That's gonna give us 96 minus 32 times 1, which is what? 64 feet per second. Okay. And not a shocker, it's positive because it was on its way up. The direction matters. What is the velocity of the ball when it is 80 feet above the ground on its way down? Okay, on its way down, we already know. It says, what's the velocity? And if it's on its way down, we better get a negative answer. So we're going to plug in the 5 now, the other time value, this one, on its way down, right, into velocity. And velocity is 96 minus 32. T, so minus 32 times 5. What is that? 96 minus, I believe that's 160, and that gives us negative 64 feet per second velocity on its way down. Okay? All right, that's the end of the notes. Thanks for listening. Bye.